So this is a follow-up on another MicroPython talk, and it's really about dealing with state in MicroPython. So in MicroPython, you can actually use hardware and software timers to get callbacks, which means you can cause periodic events to occur. And there is some weirdness about that if you're just a regular Python programmer that hasn't dealt in MicroPython before, and we'll talk about it. And the demo, of course, is, I've still got the same ESP8266 board used in another couple talks, and we can turn it's running a built-in web server. And so I can turn pins on and off, and we can make servos move. We could make servos move. There we go. Right, so we have these controls. And one of the things I wanted to be able to do was have something happen on a periodic basis, and I'm going to do something dumb here, just make a light flash, but make it happen on a periodic basis with no extra controls of my own. So if I turn that on, you can see the blue lights flashing, and basically what we did is we set up a timer at a regular interval. It just toggles the state, and I can turn that off, and now we can see that the running status is off. And, I've got other lights here, and this page is refreshed every time and it's still not running. So if I set it to true, the blinking should happen, and I should be able to play with the other LED. And you can see, even though I'm changing the status of these pins, the timer is still running and the running flag is still set to true here, right? And that's all because we are running with timer callbacks. Right? You know what? I can leave that running in the background just to be annoying. Let's do that. Okay. So basically, MicroPython supports hardware and software. You know what? I'm going to bring myself back. Hold on. All right. So I'm back. Yay. All right. So really, we're working with MicroPython callbacks, right? That's how this works. And what does that mean? And what is implied by that? Well, so to make this work, basically you have to initialize a timer with an init call, and you pass in some Python function that's going to get a callback. And if people have done Python work before, then they've seen the ability to pass a function. You can pass a function around like any other variable. It's great, right? Now, what turns out, if you initialize a timer and you run it with a callback, you're going to get that function is going to be called back on a regular basis or as a one-shot, depending if you did periodic or you did single shot, right? And the problem is, and this is a problem and not a problem, but you only get one parameter in a callback, right? And that parameter is a pointer to the timer itself. So if you need to know which timer, if you need to manipulate something like an IO pin, or you need, well, that would be what it is a lot, or you need to do some control thing, or you needed to send a message to a remote site every 3.5 minutes, you were going to send a message to some cloud server on something, right? The question is, how would you do that? Because you don't have access to like the cloud configuration or anything else in this callback handler, right? You can see the callback handler just gets the timer itself. So one of the things we need to realize when we're looking at timer, and it's not just rollover, but like any timer callback, right, is an interrupt handler. And that's something weird because it means it runs in a different thread and it's not part of the normal Python thing. You can write Python code for it, but it turns out, and so in my case, in the example program we're doing, right, this web server, let me go back to the web server. The web server is running on this all the time, but most of the time it's just idle, like in an async waiting for a request to come in on that web port, right? So what can happen is the timers can run while that thing's idle, and then my callback will happen, but it is an interrupt handler. And because it's an interrupt handler, it turns out there are all kinds of interesting restrictions. Your Python function can't really create any memory. Right? The heap is locked because you're not in it in the main thread. And so you actually end up, in my case, because I'm just blinking a light back and forth, I actually don't need any memory. I can read the state of that pin and I can flip the pin back and forth. But if I needed state, it turns out that all has to be allocated beforehand, right? So memory cannot be allocated during a callback. And this was actually aimed at exceptions. So exceptions, when they're raised, can't give any information because they can't create a message. So for exceptions in a callback, they actually have instructions around allocating 100 bytes of memory or so you have a place to put the emergency message, right? So if you need any memory in a callback, any memory in a timer rollover event or a single shot, basically the timer itself rolls over, fires an interrupt, and then resets. then you need to have that, right? So the IO, like I said, the IO pin example just doesn't allocate any memory, so it's no big deal. So I went out and looked, and because a timer callback is really an interrupt handler, it turns out there's a bunch of restrictions, and you take this into account, click on the links, and it'll give you guides on how to make some of this happen. So I have this sample app, which is on this GitHub, right? I have this sample app. And in the sample app, the part we're interested in is really this callback, right? So the main program creates a web server, runs a web server, and whenever the web server gets a request that says to start or stop the timer, right, to this periodic event, then it'll either start or stop, and then that either inits or de-inits the timer. When the timer's initted, it's going to run, and when the timer expires, it will actually end up generating an interrupt, and then either software or hardware interrupt, and then it will invoke that callback, and then if it's a repeating periodic, the timer will reset and run again, right? And hopefully it resets at the top of the IRQ, because then you got to decide on the skew and the timer length and all that kind of stuff. But the point is, the callback runs in this right-hand side, which is the timer handler. So we have a setup code, we've got configuration code for the timer, and then we've got what happens when the timer actually runs, right? So there are really two ways to hold state. And we're going to talk about the most obvious one, and that's global state, right? Since the callback functions can only receive the timer as a parameter, how are you going to get access to the pin or the hardware, the servos, or anything else? And the simplest way to do that you'll see on the internet is you have some function in a file, not in a class, in a file that's defined as a class, just simple function, and there will be some variable declared in that function, and that variable's outside the function so that it'll exist across function calls. And then you need to make sure that your function gets access to that variable. And because this stuff runs in different threads and there's a bunch of considerations, basically you just make that variable be a global, right? So if we declare that variable global inside the function, then when we need to look at the periodic target here, right, in this case that's just a pin, when we need to look at that, it's a global, so it'll point back to that. So every time the timer fires, in this example, it would call toggle pin callback with just the timer, and that toggle pin callback would actually would go to the periodic target to find the pin that it's going to flip back and forth, right? So this is the simplest way to do it, and when you make the call setup, it's super easy. You just pass the function in, right? You assume the periodic target's already been initialized, and it's only used as a global here. Nobody else knows about it. Unless they do global against that also. But in this case, this is an example of doing passing in a function. This would actually pass in the toggle pin callback into some place, and then that thing, like normally it would be on the init on the timer. This is a wrapper, but that's the idea, right? So simple function, global variables. So why is that bad? Because it turns out if you had multiple timers that were flipping back and forth different pins, all using the same function, toggle pin callback's only got one global variable it's pointing at. So all of those event handlers would be working on the same pin, right? So you just got to think about it because it's global. You could create a toggle pin callback 5, toggle pin callback 6, and then wire those in or other. But really the right way to do this is to create an object and pass the function that you pass into the callback would be a method, a function on an instance of that object. And that way you could actually new up a couple objects, and you would just pass the callback for the individual objects tied to different timers. They would be completely isolated, and they all have their own state. And if something had to happen in that object outside of the interrupt handler with those variables, you could do it, right? So let's just look at an example of that. In this case, we have toggle pin here written differently as a class. So basically, you create a toggle pin, and then that instance dot toggle pin callback you pass in. And it turns out that magically, because of the way the function is defined, when you pass it in as the callback off of one of these objects, it will actually get called back with self and t, and so it actually has access to the local periodic target. So in this case, there's no global periodic target variable. It is managed inside toggle pin. So I actually could new up a couple of these, create a couple of these, and bind them to different timers. So if I had, now the one I'm working on has only got a software timer, but if you're on like an ESP32 or a Raspberry pi 400, 2040, whatever that thing's called, right? Then you could actually bind one of these with a different pin to each of those timers if that's what you needed, right? So how does that work? Basically, this is an object, and you create one, and then you pass in the function off of that instance, right? And so here we're going to create a toggle pin with a hardware pin, so that actually calls the init method. And then in this case, instead of just passing in toggle pin callback, I think it was called before, now we're going to pass in the instance, really the object dot that method. And so every time that timer overrun happens and the callback is invoked, it will be on this copy of the toggle pin. And I can have as much variables in that toggle pin as I want, right? If I was going to call a cloud-based topic or something, then that might have the topic config in it. But I would already have to have created the memory allocation buffer to send that because I can't create anything in there. So the only other minor things are there are some interesting things you'll see. I saw this the other day. I was running that blinky light thing I just showed you, and the timer and I bopped into the REPL to just go look at something, and the light was still flashing, and the output from that kept coming even though the REPL had stopped the main program. So callbacks are hooked to interrupt handlers, and that means even if your main program stopped, the timers still run. You probably should provide yourself with a simple way, if you're going to do a lot of REPL work while working with callbacks, to stop the timers while you're in the REPL, like some utility method you could load and then run. So all of these samples came from the same MicroPython project that I've been playing with before, and I hope that tells you something about working with state in timer callbacks. Have a great day.